Hello, today we are working on this assignment right here, circles and tangent lines. Okay, so let's go ahead and open this one right here. Let's open this document here, and this will help with some of the concepts. So click on this, and then when you do it, if you want, you can do, you can file, you can make a copy, and then you can do the translation. So make sure you do that so you can translate all this stuff here, okay? Okay, so the first thing is I'm going to put this in Kami. Okay, so I open this in Kami so I can go ahead and take some notes. Okay, so the first thing is what we're doing is we've been studying circles so far, but now we're going to talk about lines that go right to the edge of the circle of a line. And what is that? Well, it's a line that touches something like a circle at one point and is, so here I show you a picture of a circle, and we already know about, let me do this, make this a little bit bigger here. There we go. So we already know about some of these. A diameter is a line, is a chord that goes through the center of the circle. A radius goes halfway from the edge of the circle to the middle. A chord goes from one point on the circle or the edge all the way to the other side, but it does not go, or at least this chord is only a chord. It does not go through the center, so it's just a chord. It's not the diameter. A secant, I don't know if we've learned about this yet, but it's a line that goes all the way through both sides of a circle. An arc is part of the circumference, part of the circle. Now let's look at tangent. That's what we're learning about today. That's a very special line. It does not go through the circle. It just touches the edge at one specific point. And where it touches at that specific point, if you draw a line from that point down to the center, it is perpendicular or forms a right triangle. So I'm going to go back to the drawing over here. So let me go back to this one over here. Okay, so if you look at this here, where the line goes through, I'm going to make this a lot bigger here for a second. It goes right and it touches at one point, and when you draw a line from that point right here all the way to, oops, drop my pen. If you draw a line from here to the middle, it's perpendicular. That's why you see the square. It's 90 degrees. It's perpendicular right here, right? Not right here. No, that's not 90 degrees. No. Only a straight line from this point there. So it is called perpendicular. Perpendicular, which if we know is 90-degree angle. So it's like this, right? Perpendicular, they go like that, form a 90-degree angle. Okay? So that's one of the principles of, or that's what a tangent line does. Okay, the first thing now we're going to look at some of the properties of a tangent line. A line is tangent to a circle if the triangle is a right triangle. So since we know that a right triangle has a 90-degree angle like that, that means if we have this tangent line here and the radius, and we form a third line, the dashed line, we create a triangle, correct? But not only a regular triangle, but a 90-degree triangle. So it is a right triangle. Okay, so if it's a right triangle, then we can figure out the sides. Okay, so we'll come back to this. Let me see if I can get rid of this thing here. Okay, well, let's look at property number 2. Okay, so here's another thing. If we have two tangent lines, remember to do the interpretate or the translation if you need to, but if we have two tangent lines and they intersect at a point outside the circle, so we have, this is a tangent line here, right? AB is a tangent line like we see right here, and CB is the other one. Those two are congruent. Congruent. Or another word for they're the same distance. So if AB is, say, 5, then BC is also 5, okay? And of course we know the radiuses are always going to be the same no matter what. Whatever this radius is the same as that. Okay, so that's property number 2. Okay, and finally property number 3 is if a polygon, like a triangle, is, this is the word, circumscribed. That means it goes, touches the circle every side of the polygon. It's got 3 sides, so it touches the circle at 3 points. If it was a 4-sided figure, it would touch 1, 2, 3, 4. It's kind of hard to draw that one, but the point is there's a triangle, so it touches at 3 places. It's called circumscribed. Then all the sides are tangent, meaning that AB is tangent at this point, BC is tangent at that point, and AC is tangent at F. Now, there's also something that's very important. Remember that this, if you look at this, it's kind of like how AB and BC are congruent or equal, correct? Well, let's look at what a circumscribed triangle does. It creates that situation 3 times. So it means that DB is going to be equal or congruent to BE, and EC, can you think about what that's congruent to? That's going to be congruent to what? To this line right here. And finally, let me see what color I can use on this one. How about purple? This one over here is congruent to this one over here. So we're going to use that to solve problems today, okay? All right, so we're going to come back to these properties. If you want to review them, you can. Remember, if it's tangent, it creates a 90-degree angle from the radius. Number 2, these lines are equal if there's from the tangent point A to a third point B, and from tangent point C to a third point B creates 2 congruent lines with the same distance. And this is another good example of it right here. Okay, so let's go ahead and look at the assignment. Back to the assignment, and that's the assignment link right here. And let's open this up here. I'm also going to open up this in Kami as well. So I'll have 2 Kamis open, okay? Okay, so the first question type is we are to determine, let me use blue, determine if line AB, this AB right here, is tangent to the circle. Well, it is tangent to the circle if, let's go back here, if it forms a 90-degree angle, right? If this is a 90-degree angle, then it's tangent. Well, what happens if you have a 90-degree angle, if it's tangent? Okay, so that's 90 degrees, right? So I already showed it up here. If it's 90 degrees, then it's tangent. So one of the ways we can check it is we can see, let me do this in blue. Is it a right, is it a right triangle? That's the question. Is it a right triangle? If it's tangent, yes. So this is tangent, so yes. But if it's not a right triangle, then it's not tangent. Okay? So let's see, I'm going to go back over here to this one, and I'm going to look at, let me make this a little bit bigger. I'm going to look at the first one. Okay, so what it means is saying, is this 90 degrees? That's really what it's asking. If 90 degrees, question mark. So if yes, then it is tangent. If no, then it's not tangent. Okay, so we need to determine that. And we're going to do that by seeing, is it a right triangle? If it's 90 degrees, is it a right triangle? If yes, then it's tangent. If no, then it's not tangent. So how do we do it? Well, we have 3 sides, 10, 10.5, and 4.5. Or we have 3 measures. And so we're going to see, we're going to use is a squared plus b squared equal to c squared. So that's what we're going to use. That's the question mark. Okay, so what do we have? Well, we have 10. The hypotenuse is going to be this one, right? That's your hypotenuse right there, okay? So we have one side, which is 10 squared plus, and then 10.5. And then you might say, is it 4.5? Well, remember, 4.5 is right here. What is this? Well, this is 10. So this whole thing right here is 14.5, okay? That's the hypotenuse. So is that equal to 14.5 squared? Okay, well, let's check it. Let's use our calculator. Okay, so what do we have? We have, what are the numbers? We have 10 squared plus 10.5 squared. Okay, close. So it is 10 squared plus, oops, now I got to go this way. Clear, and then I got to come back down, right? Ooh, hold on. 10 power 2, and then we come back down, plus 10.5 to the power 2, enter, and that's 210.25. So 210.25 for these two. Is that equal to 14.5 squared? Okay, 14.5 to the power of 2, enter, that's 210, but yes it is, isn't it? So that means these two are, okay, so that means 210.25, yes, it is equal, so yes, so that means it is tangent. So it's basically a right triangle. Now if you understand and you want to try this, go ahead and try it and see if you can see if it's tangent or not, and then I'll show you the work when after you're done trying it yourself. Okay, so this is what I got. I got 15 squared for this side. Remember, 7.5 is from here to here, so we have another 7.5 from here to here. So this side is actually 15. It's the whole diameter. So that's why I put 15 here. This side is the 8, and this is the 19, the hypotenuse. So when I did it, I got 289 over here, but on this side I got 361. So that means these are not equal, so this is not tangent. Okay, so that's how you do questions 1 and 2. Okay, so the next thing is number 3 is very similar to number 1 and 2, because what it is it says find the segment length and assume, that means that this is tangent. So assume means we're going to automatically assume that that's 90 degrees, and we're going to say it is a right triangle. Okay, so in the first one here, if you look at it, if that's the case, then what do we know? We know we're trying to figure out this piece right here, correct? Well, what do we know? Remember that any line from the center to the edge is the radius. Well, we know this is the radius from here to here, so that means 8.4 is right here, okay? So that means we have, and then what's the hypotenuse? Well, this would be the hypotenuse. So what we're going to do is we're going to take this side here, 8.4 squared, plus this side, 11.2 squared, and that's going to equal, well, we know 8.4 is part of it, plus our x over here, and this whole thing is going to be squared. Okay, so first let's do this in our calculator. Okay, so this is what I got here, and so now what I need to do is I need to get rid of that square. Do you remember how we do that? Well, we need to just basically go take the square root of this whole thing like that, okay? And then when we do the left side, what do we get? Okay, remember, if you remember, we go second, square root, 196, enter, and we get 14 over here. So we get 14 over here, and this square root gets rid of the 2, and then we get 8.4 plus x. So all we have to do is minus 8.4 minus 8.4, and when we do that, we get x is equal to, what would that be, 65.6. Okay, so that's how we do that kind of a question. Okay, so number 4 says we're looking for the perimeter of the polygon. Okay, it looks like I've run out of time, so what I'm going to do is have you make one more video. Go to the next video, okay, because we're running out of time. I can only do 15 minutes, and it looks like I've got 14 minutes. So I'm just going to do one more short video to do questions 4, and then 5 and 6, and then I'll be done. Sorry about that, but that's what I'm going to go ahead and do, okay? So go to the next video for questions 4, 5, and 6.